Yes, welcome. So for those of you who don't know me, my name is Josh Thompson. I am on Mike Sharkey's data intelligence team as a data architect. I'm working largely with the Actionable Analytics project, which is under the Provost's office, and Jennifer Wilkin and Phil Arcuria, who also just joined. Hopefully he doesn't get any surprises during this presentation. And so I'm going to tell you a little bit about what this project is, how we're going about it, and why you might want to care. Because we are really hoping that the Data Mart will not only support actionable analytics, but the greater university analytics environment. So, okay, pull it up. All right, so we're going to talk a little bit about the purpose, the placement, the plumbing, and the planning. And yes, I did rename some of those so they all started with a P. So I like alliteration. So first up, the purpose. This is going to be the what and the why of what we're doing. So I went through a few different analogies, trying to find one that really worked to explain why we're doing this and what it is. It's not a perfect analogy, it's just the best I could do. And so in order for this to work, you're going to have to kind of accept a few things. It's very much centered around the business creating data, but that data is going to be in the form of dirt. All right, so here we are, waste is dirt, dirt is good, and let's get going. All right, so this is ASU. This is obviously the Tempe campus. We're going to pretend it's all of ASU. I also need to figure out how to get into presenter mode because this one's going to be really hard without notes. Give me one sec. There we go. That'll help. Okay, so this concept isn't necessarily specific to ASU or to higher ed. What we're really looking at is the university as a business in general, okay? And any business in this analogy is represented by a city. So the people, the buildings, the infrastructure of the city, that's the day-to-day operations that keep it running. Okay, there they are. So this business is creating data, and that data is piled in and around the city as rock and dirt to form hills and mountains. Although it just doesn't happen to exist a whole lot in our area, let's pretend there's also hills and mountains in the middle of the city, all over. Okay, so here we are, we're generating data. So different piles contain different data from different sources. Each location provides a different perspective of the business. The higher up the pile you go, the broader the perspective, but the lower the detail, right? So if you're used to hiking around the valley, you're probably familiar with a lot of these concepts. We get some great views. Now, the data warehouse creates a lot of these mountains of data for us, right? So they dump similar data in similar areas. They ensure that we get solid rocks and dirt, not just garbage that's going to deteriorate. They prevent voids from forming under the surface. And they provide security gates at the base of each pile to make sure that it's only being accessed by those who should be there. So the more piles and the larger piles they create provide additional opportunities for new perspectives of the business. In a traditional, not so data-driven organization, data might get collected, but is then often not used. What you really need are data explorers to evaluate the terrain and identify opportunities for development. So business users venture out into, they can find interesting spots. They can even take snapshots. which are essentially reports of what they see, and bring it back to the business. However, the reach is often limited due to other responsibilities, limited training, and they don't necessarily possess the mechanisms to make that same spot in the data easily accessible for return trips or for sharing with their colleagues. So tools like Hyperion, MyReports, Power Query, they remove a lot of these barriers, and they provide options to return to the same spots in the data more quickly, consistently. Essentially, trails. Now, dedicated data analysts, these are people that have the time, they have the training, they have the equipment, they get to venture further into the data and blaze new trails. Researchers focus on the details provided by these data-driven vantage points, right? They're finding a spot and they're just really drilling down into it and figuring out what's going on within the business from that perspective. Completed research projects, they might be persisted, like a photograph, in the form of something like a model-based dashboard, like something you might find with Civitas Illume. And that can provide updated views through this detailed lens, right? So from that same vantage point, just getting a clearer picture, but of a very limited area. So then we get tools like Alteryx. They make the exploration faster, repeatable, and they really open up options for large-scale development. Now, ultimately, executives don't have the patience to hike up in the mountains. Luckily, they can afford jetpacks. Now, they could just fly up and look down, but it would be a perspective based solely on intuition, not data. What they really want is a comfortable and informed location to plop down among the data for a bit in order to see what's happening in the city below. And I'm picking on Art here because he likes to ask lots of data questions. Unfortunately, what we usually provide them is not quite what they purchased from the brochure. Okay, and what other options really are there? We've got limited tools, we've got limited time. Well, we've added new platforms at the enterprise level. For instance, analytics.ac.edu, right? The ability for teams to enclose their products, provide new security options for those who are flying in, well above the security gates at the base of the mountain below, for better or worse. Now, with enough skill and effort, some amazing products have been and will continue to be built. But building something like this on rough terrain is difficult, dangerous, not easily replaced if it's broken, and definitely not easily replicated elsewhere because it's so custom, so tailored. So these large projects are easier, more reliable, and repeatable when they're built on a plot of land that has already been leveled. Okay, so enter user databases. Right. Within the user databases, units can now create a solid platform in the data to construct their enclosures and viewing platforms much more rapidly. After the initial effort to kind of clean, make the data more consistent, create some focused data sets, it's a lot easier to create user-facing products with the data. So they scrape the surface that's already there. They bring in additional data from their own sources to try to level that plot of land. But what if you want to build enterprise-level facilities or entire neighborhoods? Enterprise-level data marts. So in these, work is done to prepare data, not for citizens and end users, like most of the analysts around the university focus on, but preparing data for analysts to use to make their work more efficient and effective. These sources create broad data platforms for development by units, increase stability, and they ease further development. Units can add their custom data and logic to build higher, connect their own marts, or even just place their user-focused products on top of the data mart. From a programming perspective, it's the equivalent of being able to use a library instead of coding all your functions from scratch. So in order to kind of accomplish this, there's 6 different aspects that we're considering. We want to make sure that whatever we build is convenient for access. And in order to do that, we're doing most of it within Redshift. The warehouse uses best practices. It's generally where we reflect the best source of truth. We want to cut out the noise, make these sources easy to find, identify. Then we want to make sure that the information is curated. So we don't want to put everything in the Mart. We only want to put the stuff that's most likely going to be useful to someone downstream. All right, so we're picking and choosing our data based on what might be most meaningful to the business. We want to make sure that whatever we construct has been vetted by the subject matter experts, right? We want to make sure that it's trusted data, that people can just go in, have faith in it, use it, not have to worry about it not matching everything else. We want to create intuitive structures, and we're creating logical naming conventions. So what we're hoping is that this will allow people to more easily understand what the data is without having to go to a data dictionary, make it easier for them to find what they want without having to go to data glossary. Still, if there's maybe details that aren't captured within a simple name, we want to make sure that all this is documented, right? So we're going to be putting full data dictionary, data glossary, in Calibra, where you can find all your other data information. And then finally, we want to make sure that the data we create is specifically optimized for the use cases that are needed by downstream users to support student success, right? And we do this with all these other things, right? Curated data, vetted data, intuitive structures, documentation. All right, so within the general data insight process that a lot of you are probably familiar with, we are identifying a problem, identifying data, connecting to that data, persisting that data, exploring the data, and then we create products using the data, evaluate those products to try to gain some sort of insight, and then use those insights to make business decisions. Where the data mart is focused is really on improving number 5. So making it easier to explore the data and relate it to business processes. Okay. So from a lot of your perspectives, what that means is we're supporting college data needs. We're creating a curated source of student data. But what we're also hoping to do is create a channel for getting additional data into the warehouse. So there might be something out there that you have found is relevant to student success. And we want to try to at least make it a little bit easier to incorporate that with the rest of the enterprise data assets. So we've got the Mart right in the middle here. So we're pulling in student data. And the Actionable Analytics project has 3 different products they're building: Campaign Builder, Predictive Models, and Dashboards. So its primary focus is very much to support those products. However, because of what we're building, how we're building it, and what the colleges are doing, it's almost certainly going to support you as well. And there's 2 different approaches we're taking to this. We're doing proactive development and reactive development. I'll talk a little bit more about those later. And then we also want to, like I mentioned, create a pathway for incorporating data that's being generated from something other than traditional student sources. So allowing colleges to give us data, taking the data that we're getting out of our predictive models and making that available on the Mart. And then we're also creating from each of these platforms product data that's used to evaluate the products themselves. All right, well, that got cut off. Ultimately, what we're trying to do is reduce the barrier to entry for ASU student success data. I've spent several years now, using student data, trying to find it, transform it, clean it up. We want to do that for you as much as plausible. All right, so placement, the second P, where this is going to live. So from a functional perspective, this is kind of at a high level what the overall data analytics environment looks like. And what we're doing is creating, again, that clean, structured, and business aligned data that's really intended to support that kind of data night level user. And it lives within the warehouse. So it's enriched, higher level, more processed data within the warehouse, specifically for student success. And it's going to be accessible by all these other platforms as any warehouse data would be. Permissions might be a little bit different, but it's there. All right, third P, how we're going to do this. So some of you out there might be familiar with this diagram, which from here, totally illegible. But what it's doing is identifying the student journey and trying to get to what information, what data is captured across the student journey. So going from left to right is essentially first contact to graduation. And then we have different roles along the rows. But this is one form of a conceptual model that's used to record information about the business and how it functions. This was done by a consultant that was brought in by the provost office, Donna, don't remember her last name at the moment. She does lots of Dataversity presentations, if you're familiar with that area. And then the other one she did was more of a physical data model. So these are the actual tables out there and how they're related to each other. Actually, this one's probably more logical than physical. But this type of information can help us identify what's out there, what might be useful, how it's related to each other. And that is going to form the foundation of what we're developing. So right now, everything's kind of spread out, complex, inconsistent. We want to try to, again, curate that, make it a little bit more tangible. All right, so within the data itself, kind of thinking about that first diagram over time, and then the roles a little bit, there are different aspects of the data that we want to make sure we capture. So time periods, different ways to measure data, to aggregate data. As of right now, by the minute, the hour, the day, the week, the month, the quarter, different types of years, academic time periods, term sessions. So we're going to be factoring in all of these where they make sense. Obviously, functioning within the warehouse, at least initially, we're going to be a bit limited. Doing something by minutes, by hour, a little more challenging when your data is captured daily. And then the different types of measurement points. So at application, at admission, when enrollment opens, right? These are relative points in time, not necessarily reoccurring points in time, like you'd see in the left column, but they're also things that we want to make sure we've captured, because you might want to measure relative to one of these if the business process is relevant with one of these. So visually, you can kind of lay things out, and you can see how the reoccurring points interact with the relative points. So down here in the bottom right, we've got some of those relative points. And what you get with these bars to either side are how they relate. So you might be looking at student relative to a class they're taking. We'll call that class B, which is in session B, which is across the same time period as session C, which aligns with the fall term, which occurs through these months of these years. But what we might get is, as of day X of class B, this student has a grade of Y, right? So these are these relative measurement points. We're used to looking at things, what was the student's academic program for fall 2020? But what we have to acknowledge as part of analytic data development, analytic product development, is a student might have multiple academic programs in fall 2020, and those could change over time as they add concurrent programs, as they change programs. And so what we want to do is not as of fall 2020, but as of day 6 of fall 2020, what were the academic programs? So we're trying to capture these relative points in time. We'll show a little bit how we're going to do that. But for kind of all these different concepts, what we're trying to build that I think most supports the greater enterprise are these, what we're calling core tables. And so we're taking all of these relative time periods and we're measuring students, instructors, classes as of these points in time, and we're aggregating activity. So I mentioned, what's a student grade, but it might be also something like, how long has it been since their last assignment was graded, right? So anything that potentially is analytic value can be aggregated into these different levels: student level, student class level, student term levels, which you might find with student by term, student term plan, student profile table, right? So there's already data out there that goes in this direction. We're looking to take it a step further. We're going to make it longer by capturing more changes. We're going to make it wider by adding additional attributes. And again, it's going to be within this logical structure with these naming conventions that we're using for the rest of the project. I'll tell you, I got a question out there. Is there storage concerns based on saving so much time on specific data? So I'm going to talk a little bit more about that in a few minutes. And Elizabeth, kind of along the same lines, we'll get to that. All right, so let's go here. So I talked about the activity, right? So these are outcomes that we want to factor in. So when you're looking at a predictive model, right, you're trying to predict some sort of outcome. If you're looking at a dashboard, you're trying to measure some sort of outcome, whether it's GPA, retention, lots of different options. Also, what we're trying to do is predict something that might occur within the future. And in order to do that, we have to know if it happened in the past to train those models or to evaluate that process. So we're making sure to capture not just the characteristics of a student, like their academic program, but also what came out of what they did at that point in time. All right. So like I said, we're focused very much on the Actionable Analytics products. I threw together some examples here of what some of the tables that would be built for those products look like, what kind of information is captured within them, what their structure is. So if we look at something like Campaign Builder, which is a product that allows you to identify a subset of the student population based on however many variables, and use that student list to create some sort of an outreach, whether it's sending them an email, whether it's sending them a text message, sending them a mobile app push is one of the options. It's really just, we want to know about this student right now. Do they fit these qualities right now? If we look at something more in the modeling area, we need to know the right now in order to process the model, but we needed those relative point in time, essentially snapshots, in order to create the model in the first place. So what was that student's academic program as of day 6 of the fall term for the last 4 years? That's the level of detail required to create these products. If you want to do something like year-over-year dashboard, again, that's point in time relative student characteristics. Dashboard. All right. Okay, so I mentioned time periods, mentioned activities, objects. So this is kind of how they all come together. There's a logical relationship between all these different elements that creates different levels of aggregation, that type of thing. So here we have one of the tables we're working on right now, student academic year level. So the granularity, 1 record per student per academic year at a high level. Again, there's that relative point in time aspect, which is added on. So it's as of date X, date Y, date Z. But this is the key components. So in order to build this, we've built a student object and an academic year object. We can intersect those, interact those to create the foundation for this table. So that's your insert into table, these things. Now, that gets you your granularity, that gets you your rows. We still need to fill out the columns. In order to do that, we might aggregate data from the student term level. So we might want to know we might create a primary degree program for a student in an academic year based on the primary degree program for each term. If they had the same degree program for 2 terms out of the year, that's their primary, something like that. Or we might say, what was their GPA at the beginning of the year, at the end of the year? But it allows us to, again, aggregate up, roll up information. That student term table would have been created with that same student object, but now we also have this term object down here. And we can keep going. So student career term might feed into student term. That's a level of aggregation. Now we have a career object, and we're interacting these 3. Then there's some, it's not a time period, it's not a student. We've got these other objects, right? These are the rows from that early conceptual diagram, potentially. A class. So class is a unique item. If you're very familiar with the data, you'll know it's a student and a career and a class section. But what we're going to be doing is just saying it's a class. We're going to give every object its own unique ID. And student in a term can register for a class. That's a registration record. But registration has that, again, that career aspect, which can make using the data complicated. So we're going to create some sort of logic to roll that up into a student class level table, which is much more usable for most analytical functions. And that can then also be rolled up to student career term if you wanted to, or student term, or even student academic year, right? So it's all about interactions, aggregations, and then in order to fill in the columns, right? So all this has just been rows. To fill in the columns again, we're aggregating activity at these levels of granularity. So we've got core tables built up from simpler tables. These are the core tables. These are simpler tables. And we can aggregate it. All right, so here, this is the overall current architecture for the Actionable Analytics project. We've got our product-focused assets up here, things for campaign builder, TBD, user databases are used for dashboards and predictive models, most likely. And then we've got some S3 stuff using that's being used specifically for predictive modeling. And a lot of what we're building up here is reactive. So we have an immediate need that has to be met. And we're using whatever's available to meet that need. This is the traditional development approach across the university. We use what we have to build what we need. The problem is, as the complexity increases in this space, you run into processing issues. The logic gets too complicated, the data gets too large, and ultimately all you're doing is stressing the servers. So in order to address that, we need these core tables. These core tables, again, are built from interacting those objects. So we've got something like student term table, student academic year table, instructor term table. These are built to support the end products. We pre-process the raw data to create more usable data that then requires less logic in order to use within a product. And as I mentioned on the last slide, the activity data, so something like student registration, financial awards, grades, LMS activity, all that gets aggregated into these core objects. So here we get something like the student profile table, and you might have something like a student profile snapshot table. That is essentially what we're trying to create here. But we want to do it in a slightly different way in order to try to make it a little bit more efficient, a little more effective. So what we're doing on the storage side is creating what we're calling slowly changing things. If you're familiar with type 2 dimensions, it's very much along those lines, other than it's not really a dimension most of the time. We're not using surrogate keys or anything like that. But what we're doing is creating some sort of a denormalized, somewhat denormalized data asset and capturing all the changes. So anytime it changes, we get a new row. And then there's dates telling you when that row started and then the date that that row changed. And with that information, we've created a storage mechanism that requires less space than you get with a snapshot. And it's easier to use than something that would be like a true log. Anytime anything changes, anywhere you get a single record, because aggregating logs can be complicated. Here, we can take this and easily create something we're calling a simulated snapshot. So to the end user, it looks like we snapshotted all this data. But again, we have a more efficient storage mechanism behind it. And we can also say, okay, well, we just want to know the current value. We can do that as well. And those are both easily done using these slowly changing things. And so each of these, the current, the snapshot, as talked about a few slides ago, feeds in different aspects of these products or different aspects of potentially college products. Yes, so slowly changing things, capture all changes, don't lose any history, more efficient than snapshots, more useful than logs, and we generate those assets off of it. So anytime you see _SCT on a table in the data mart, that's what this is. Anytime you see _CUR, it's just the current version of the slowly changing thing. Anytime you see SSMP, it's a simulated snapshot of that data. It's got a simulated snapshot date, just like you'd have a snapshot date and snapshot table. And then the SCT has this row valid start date, row valid end date. If you just go straight to the SCT, make sure you're using these dates, because otherwise you get a lot of data. And it's not necessarily useful. All right, so in addition to all the work we're doing trying to create physical data assets, we're also trying to get into the documentation game a little bit. So we've started by creating a conceptual model. Now, back here, you saw a conceptual model, much more complexity than what you necessarily need to capture in order to inform someone specifically of data use. This will tell you everything about everything about the university. We don't need to know everything about the university. We just need to know everything about the university that affects the data, and specifically the relevant data. So we're taking something like this, we're removing the time aspect of it, and we're looking specifically at object relationship. We've got objects, we've got relationships between those objects, and then we have attributes of the objects and relationships. So information about objects, information about relationships. And what we want to do is create this as a point of entry. So if someone says, I want to measure process X, or I want more information about thing Y, you can figure out what that is, what it's related to, and use this as an entry point to try to find the data. So the next layer is a logical model. Don't have an example for you here, but what it's doing is creating this functional structure for the data. So it's still reflective of the business process, but it's not necessarily exactly what you're going to see in the warehouse, right? So we might have a student term level data area. Don't want to call it domain, that's something else. But we're not going to have an object for the slowly changing thing, an object for the current view, an object for the simulated snapshot view. That's just too much detail for this level. So this is somewhere between the conceptual level and the physical level. So physical model, typical ERD, this is exactly what's in the database, what the relationships are, all their attributes. And hopefully, this is what kind of allows people to know what is where and identify what they want to use. Now, we've had some upgrades recently in the Calibra space where we've started in on the business glossary and the data dictionary. The business glossary is business descriptions. Data dictionary is data descriptions. And you might be thinking, hey, this is kind of business descriptions. And this is kind of along the lines of data descriptions, right? So those are related. And so what we want to do is try to create an integrated model. So how do we bring together business glossary, concept model, logical model, physical model, data dictionary, and allow people some sort of an interface where they can actually traverse those. So they can find out information about the data, how that relates to a business process, all in one place. End goal. See how that goes. Okay, planning. So when and who. I believe this is our last P. So Phil stole your yesterday on this one. Right now, we're kind of working in parallel on 3 different aspects of the project. We're doing the reactive development, very much thinking about the predictive models. And so we're capturing the outputs from those models, and we're also working on inputs for the next round of models. With the core tables, that intermediate level that I think most people are going to be interested in, we're working on the student academic / aid year. Those are academic years are same thing as aid year. And up next, I'm thinking it's probably going to be student term, but we'll see. There's some debate to be had there. And then on the proactive side, right now we're working on service indicator tables. And a lot of what we're doing in the proactive space is just trying to capture data that's traditionally lost. So we pick service indicators because we know that there are some service indicators. I'm not going to name any names, but there is no reliable history for the impact of certain service indicators, or even for when a service indicator had been applied to a student in the past. Again, for some service indicators, even the audit table isn't really reliable. So we're focusing on that because we know that data is going to be important down the road for analytic use, but we're currently losing it. So Same thing with enrollment data. That's going to be what we're going to do next. We know that enrollment records get manually manipulated, get deleted, and when you want that relative historical point in time snapshot type of aspect, you can't lose data. So right now with the proactive side, we're trying to kind of plug the holes in order to, down the road, support those reactive needs. So these are some of the areas we've been looking at, some of the different granularities. So student level, student term, student class, academic year. The objects we're looking at. So terms, classes, courses, plans, like these are additional elements to provide context to the activity data, right? To create those different granularities, because we've got student stuff, but you might want a instructor term or something with class and plan or course and plan would be really interesting, I think. So these different ways we can interact the data to create contextual data for analytic use. And then those objects, those would actually look a lot like a type 2 dimension. Again, not a formal dimension. And then activity. So different things that students do or that affect student, and trying to make sure that we know what happened when, so that we can aggregate it to those different core table granularities. So we have some outstanding questions. Some of you have been involved in conversations around our naming conventions. There was a discussion in, I believe, the Where's That Data Slack channel recently about the identity merge process indirectly. We're still trying to figure out some details there. How do we kind of mix census data with PeopleSoft data? So there's a lot of things that we still need to figure out in order for this to really be effective. And so these are ongoing debates. And this is the team. I believe this is updated. Phil, please let me know if I'm missing anyone. We're just kind of getting covered down there with the text box, but we've got lots of people building the models right now. That's where the project started, with the creative models. And we've got people supporting that, but we also just got a dashboard developer. Discussions are really starting to gain some traction with the campaign builder development. So there will probably be some actual front-end developers added to this list pretty soon. But it really is collaborative between the Actionable Analytics proper, headed by Phil, as well as other people in the Provost office, like Diana. I guess Larry's not there anymore, that's not updated. And Trey. And then people within UTO, especially the warehouse team, because the data mart is obviously going to be taking up some resources there. And Kiowa doing the predictive models. And we don't want to leave out the SMEs that are working with us and the data stewards, because there's a lot of complexity there that they're kind of helping us out with in order to make all this work. All right, I made it on time. We got time for questions.
Well, I'll pipe in with a question if nobody has one initially. So with a lot of the things that are being built, you showed that diagram with the ERDs so that people would get, anybody who's looking at it would have a better idea. Is there a plan? So with some of that data denormalized, what are the plans, and how would a user find rules for what was developed or determine the SET joining that they need to maybe do? Is there a plan for those diagrams somewhere, or how would they know what those business rules are? What does that look like in the early discussion, right? Because it's not there yet, right? That's the end goal, but what might that look like in planning?
Yeah, so I think that's really where the interaction of the different types of diagrams is going to be the most beneficial, because the relationships between the tables, a lot of the complexity will be captured in the higher level, the logical and the conceptual levels. Like, just because you see field A in this table and field A in this table doesn't mean you want to join those. And we're hoping that we can use the business processes and the logical layer to inform the physical connections. Because we don't want to document all the possible connections, right? We want to document the connections that relate to the business processes that are trying to be measured.
So there's kind of two layers,
right
the
now,
ERD, so where it, what the connections are, but then also what's that underlying logic? How can I determine that for the underlying SET components that you talked about, right?
Yeah. So it's, it's going to be, a lot of it's going to be interface dependent. I can't develop any of this. So this all assumes there is someone who's going to be able to develop this
work through that.
But it's, a lot of this is going to kind of be generated essentially in real time, right? It's not just a static diagram of all the tables with connections. That's not how it works. It's, you've selected a domain or some sort of a function that you're interested in, and it's generating the relationships you need based on the metadata that's captured on the back end of this system. So there will be a box for a table with a list of fields in it, and there will be lines connecting columns between those tables like you get within an ERD. But that's not necessarily the only thing that's stored. It's all context dependent.
Of course.
It's all very conceptual at this point.
Yeah. I think that's something that is needed. That's great. Today is having some sort of live ERD. How can you drill in? What do you know? What's connecting? And some of the underlying business rules. I think there's Google spreadsheets out there that say, here's what this, that kind of thing. But I think that's awesome design for where we need to go, for sure.
Yeah, and it's, some people might come from places where you have a warehouse that has defined foreign keys, right? It's like, oh, why don't you just shove it onto Irwin and have them generate the ERD for you? Well, that's not how we do things. We can't fall back on foreign keys for these relationships.
Right, and we do have a question from Nicholas Romano. Will this type of structure work? Sorry, I got to move this over. Will this type of structure work its way to students in the form of dashboards to help understand their own performance related to other students currently in the current time and history?
So that's actually something I wanted to do for a long time. Like, embedded analytics within my ASU would be so cool. There's a lot of political issues around this. I'd be curious to see if Mike or Phil want to chime in though.
Yeah, I can comment on it. No, Nicholas, it's a great question. Thanks for asking. What Josh said is right. I think there's value there, but it opens up a lot of potential cans of worms. We try and do a good job of being very open about what we do. Actually, last year at this conference, if folks were at this conference in the MU last year, we had a student panel, and we had the students talk about their thoughts and impressions on data, and the fact that we have lots of data. So there are folks on our side, a lot of people here that are like, yeah, we've got a lot, this is great, let's use it for good things. And there are folks that say, wait a minute, what about me and when I did what and when and where, and pump the brakes, don't do that. So that makes it a bit harder, unfortunately. I wish we could trust everyone that people say, look, thank you, ASU, you're trying to do good things with the data, go right ahead. But rightfully so, other people are cautious and saying, hey, so when we start exposing that to students, it opens up that level. So it's a great conversation to have. There are definitely things we can do. The you are here, we've had stuff in courses like, here's how you're progressing on some kind of measure of completeness versus everybody else. That's great. A lot of students will feel motivated. some students might feel demotivated. They might feel like, oh man, I'm really behind. I might as well just drop my class right now and go home. So those are a lot of things we got to take into account.
Yeah, and I would just add to Mike's thoughts is, it's the technical challenge is the easy challenge, right? We have to make sure that the application of the data and the presentation of the data can't outpace where we are as an organization in terms of our quantitative literacy and how we interpret this data appropriately. So there's this the concept in psychometrics called consequential validity, right? So what is the outcome of someone using this data, not its intended purpose, but how it's actually applied. And we have to make sure that a number one thing is do no harm, right? And second thing is that it does good. So we need to reflect on everything that we do. At the very least, can we make the reasonable assumption that it will do no harm? Check. Then next is say, can this actually provide good? And work through that in every scenario, in every context, before we make the decision of putting that out. And that applies both on the staff side as well as the student side.
See, Jennifer Wilkin might be with us. Be curious to see her thoughts on this too.
I'm here, I'm listening. You guys are doing great.
And also somebody just posted in the chat the Netflix, so the social dilemma as a reminder. Yeah. Mm-hmm.
All right, any last quick questions, comments, concerns?
So not a question, but just kind of a few points. One, just going to reinforce what Josh is saying. Even though a lot of what we're doing is to support that product suite within Actionable Analytics, really our larger kind of perspective and purpose is to service the broader ASU analytic community. So even though that's kind of driving what we're doing, we're also having an eye on what are the needs of that community and how we could best service that with what we do. And the second thing is, as Josh and the data warehouse team can tell you, the back end side of things is not my area of expertise. So they've been great in bringing me up to speed. But I just want to acknowledge the work that Ezzy did by creating this concept of a slowly changing table, and her work with Josh and Laura Lee. So to me, who's naive, I think, oh wow, that's simple solution, but it took a lot of hard thought and a lot of ingenuity with coming up with that solution, so we can do the things we need to do in an efficient and effective way. So just wanted to acknowledge her efforts as well as Josh and Laura.
And hopefully Laura and Ezzy aren't too upset that I had the current on there a few times.
As you mentioned, conceptual. We're still working through these
Visual,
things,
yes.
right?
We don't have any new questions, and we're almost at the time.
Document on the SCT design. There's a Jira ticket we've got out there. Laura, Ezzy, do you guys have a Google Doc or anything on that?
So Josh and Phil, I would take this chance to say, Mark, let's meet and talk about your projects.
Yeah, absolutely. Happy to meet Mark, and we have some standing meetings between the group of us. So I'll reach out to you, see if you might be free. You could join us for one of those. We could talk through it, or some way we'll sync up with you.
Right. I think we're about at time. Yes.
In about 5 minutes.
Wow.
5 minutes.
That was 10:20. Wow.
Was it 10:20? Oh, we're just past it then. 10:20, 10:30.
Oh. Are we way past it?
It's 10:20. 10:30.
Is it 2020? Yeah, so we blew past, but it was good questions, answers.
Okay. Well, I should probably jump to my other presentation then.
Thank you all for joining.
Thanks, everyone.
Thanks, Josh.